All right, so let's talk about software life cycles and why. You can see from this chart, pretty much the conclusion of this chart is the later you find your errors, the more costly it's going to be, and by significant amounts. If you have bugs in your beta testing, your post release, those are expensive. Your customers get mad too. They're hard to fix. If you've ever used software on release day and it was buggy, you know what this is like from the user perspective. You don't want to do this from the developer perspective. It's expensive, it's stressful, it's just all around bad for everybody. Bad, bad, bad. This is plagiarism. No, it's, I mean, Matt Hertz said, "Here are my slides for 442. You can use these for your course." It's not plagiarism. This is, though I am stealing his style now, maybe that's plagiarism. I didn't ask him if I could wear a Hawaiian shirt, but all right. So but I have his full permission and endorsement to use his slides. So let's talk about this through a story. We're going to talk about two developers. We have a client who's hiring. Identity theft is not a joke, Jim. We have two software engineers who are working for the same client, and they have two different styles of Programming. I would say that, but it feels like too much of a demand. I'll just take requests like that. If it comes up naturally, I might say it. So let's talk about them. So Bob, he codes the same way he does in college. You all know this style. We'll talk about it throughout this example. Joe, on the other hand, paid attention to this course, to her CSE 442, and applies the concepts that she learned in there and actually uses some lifecycle models. So let's walk through the project and see how both Bob and Joe treat this project and what they do at each step. So first, the client hands over some notes, says, "This is what I want to see in my software." Bob says, "Cool." Takes those notes, starts coding, starts writing some tests. This is a pretty good student who's going to write some test cases, and gets in the code and just starts writing code. He doesn't want to waste time. He just wants to get in there and deliver to the customer. Joe, on the other hand, she says, "Well, these notes are great, but I need a little more information." She goes back to the client and gets some more information from them, starts to figure out what the needs of the client are, not just these, very sketched out notes, and really spend some time with the client to figure out what the software should actually be. So Joe is going to be more expensive at this part. Bob just jumped in the code, started typing. Joe is adding some extra cost here to meet with the client and figure out what the client's actual needs are. As Bob is just haphazardly writing code, there's often duplicate code. The project gets stalled a bit because he wasn't planning anything out. On the other hand, Joe is designing her code more, spending more time on the whiteboard and less time at the keyboard, which I always recommend. Actually mapping out the modules and figuring out what this code should look like before just jumping in and coding. And also revising those requirements. So based on this extra meeting, revising those requirements and getting software that's more accurately reflecting what the client needs. Once Bob gets going, he's just typical lack of planning. The student way of coding, no planning, just dives in. So a lot of code isn't being reused. There's not common modules that are called in multiple places of the code. It's just everything's built from the ground up and built as it's needed. So no planning, none of that. Joe is planning. She's outlining what she needs, what modules she needs, and refactors things when needed. Factors out common functionality, puts those in separate modules, all that good stuff that we learn about with object-oriented programming, for example. All those ideas she's doing. So much cleaner code, much better organized code. But of course, Joe is still spending more money at this point from that initial meeting. But Bob, at least in this example, spending more time just making a step forward, then having to erase something and go backwards a little bit. So spending a bit more time redoing extra work. Not that Joe isn't doing anything, but any of that rework, but Uh, Bob's code isn't going to be used in future products, and Joe's can reuse some of that code, is going to have detailed tests for the system, but not specific code for the system, which is an important distinction. So her code can be used throughout systems, other systems, and this is one thing. When you're working for a while, you're developing a lot of software. You tend to have a common like library of things that you always use, or at least if you have good practices. You have a common library of code that you use in a lot of different projects, and that code will move around to other projects, and you're going to reuse that code. You'll be building your own libraries for all those common tasks that you like to do. That's what Joe's doing. She's going to make those common libraries that can be reused. So for this project, she's reusing code from past projects. For her next project, she'll reuse code from this project, because she has everything nice and modular and set up in a way that she can do that. Bob doesn't. And finally, we get close to deadline, and Bob is just working tons of extra time. You've all done this as students, probably in every class, most at least classes you've had. You're just diving into the code, not looking ahead at all, just trying to get the task right in front of your face done any way possible, and not really thinking of anything else. Once you get close to the deadline, you start realizing, holy crap, this has to get done now, and you start pulling those all-nighters. You start putting in all that time. And that's when students come to me and they're like, I put in 40 hours into this project over the last 3 days, before the deadline. And I ask, how much time did you spend last week on it? How much time did you spend planning? Or did you just jump into the code and start whacking your keyboard and then wondering why nothing works? That's what Bob's doing, just whacking the keyboard. And once it gets close to time to deliver, he's stressed. He's working a lot. Joe, on the other hand, she's relaxed at the end. She has everything clearly defined, even with tests. Everything's confirmed to work. Everything's functional. And at this point, she doesn't even need her talents to be able to do this final delivery of the project. Everything just comes together so well that it just works. It's working well. So at the end, Bob's super stressed. Joe's very relaxed and just hanging out. So Bob, kind of delivered what the customer was asking for. The program's not great, and the GUI doesn't reflect what was in the contract. Joe, on the other hand, well rested, meets all the needs of the customer after having that additional meeting, met all their needs, not just what they were asking for in their notes, but their needs. The code is reliable, robust, it always works, and the GUI's mostly correct. There are a few things different with the GUI. So which team wins? Neither of them. Customer only cared about the GUI, so sorry, Bob and Joe. Joe, you worked hard. You did most of the right things, but you're both fired. Plot twist. So the client valued the GUI design over anything. This is very common with clients. They're only going to care about the GUI. They don't really care about how good your code is. Now, don't get me wrong. Joe did tons of stuff right. That Joe is the good example there. But writing quality code and using all those things that she did, it's not enough. It's not the only thing that you need to do. The GUI is going to care about the client is going to care about the GUI. They care about what that software looks like, even if it doesn't work very well behind the scenes. How much software is out there in life that you use where the GUI is great, but when you click a button, it just doesn't do what you expect it to do, or you got to wait forever for it. It just kind of sucks. But hey, the GUI shows all the features. I'm looking at you, UB Hub. And Blackboard, it's UB Learns and UB Hub are two great examples of pretty terrible software that we all have to use because, well, it delivered the right GUI. It technically has the features that it promises. Anyway, they both had inappropriate models. They were both very focused on the code being, well, Bob wasn't too focused on anything. Joe was focused on the code being correct, but not necessarily having it look nice on the front end. So at least Joe's going to have a better time in the future. She's got some extra libraries she can work with that's going to help her on her next project. The customer was happier with her than with Bob, but, still not great. So software development, life cycles, software models have really evolved using a Darwin approach, where we just kind of, as an industry, have come up with some models. Some of them work okay. Some of them have strengths and weaknesses. Some of them are just terrible. But it's just survival of the fittest. So we're going to talk about a lot of the models that kind of stuck around longer than others. And then we'll wrap up with one that has been standing the test of time and is starting to take over in industry quite a bit. Which, spoiler alert, but it's going to be Scrum, which is an implementation of Agile development. Okay, so let's start with the classroom development that Bob used. You're always starting from scratch. I mean, you've seen this before. We have perfect requirements. You might argue this point, from time to time. Sometimes our write-ups aren't perfect, but you have the requirements clearly defined for you. This is what you have to do. Most of these assignments are write a method or a function or a class that does X, Y, and Z. You gotta have an auto grader, so your testing is done for you, though you should always write your own tests anyway. You submit, you figure out if you did it right or wrong. And you're able to just dive right into the coding, and you're not concerned about the structure or any good designs of your code, because you're just going to throw it away after the assignment's over anyway. You can't reuse it, which is fine, because you can't reuse it. You're not going to do that assignment again. So, I mean, that's just the nature of classroom projects. They're designed this way on purpose because you're learning other things. You're learning software engineering this semester. You weren't learning it in other semesters. You're 115, 116, 220, 250, and all the other, your other CSE courses. You're learning other things in those courses. So we do the development lifecycle for you. We gather the requirements. We analyze it. We deliver the deliverables to you. We have a very defined contract in the homework assignment handout. And then you just jump right to the coding. And these projects are all, think of the most challenging, difficult homework assignment you've ever done, programming assignment you've ever done. It's still a joke. Like, there's nothing we have you do in the undergrad level that's anywhere near comparable to a real world project. Anything that you do for a project, obviously it can be done in a few weeks by an undergrad student. It's not challenging enough to be a real world project, like for what it's worth. So once the projects do become big, that's when these software engineering practices really do come into play. You don't want to go into a big project and just kind of hack at it like you would a homework assignment, including this semester's project. You don't want to just hack at that like you would. I mean, you can. Some of you will. Possibly most of you will. But you're going to have a bad time. So let's talk about a few of these. Let's start with Waterfall. This is the first kind of maybe not natural. Yeah, they've all been a joke. I mean, take it with a grain of salt. I mean, compared to any industry project. Let me ease up on that just so you don't cry too much. But industry projects take teams of software engineers, years to create in most cases. The homework assignments aren't jokes in that they shouldn't have been stressful and difficult for you, but they are jokes in that they have no value out in the real world, because an undergrad student can complete them in less than a couple months. There's just not that much to be done. Let me reword that again. We can't fit a larger project in any of our courses because we only have one semester. We got 15 weeks for you to be able to do that, and we got to teach you how to do it and then give you time to do it. And also, we're aware that you have 3 to 4 other classes or sometimes more at the same time. Some of you have jobs and home lives and social lives and stuff. We can't just demand 40 hours a week of your time like a job can. So there's a reason for that, but yeah, nothing you've worked on compared to industry, the software you'll see in industry, it's nothing. You ain't seen nothing yet. Unless you had an internship. Without real world projects, use Stack Overflow. Yeah, I didn't say they don't use Stack Overflow. Google and Stack Overflow are developers' best friends, even senior devs. There's just too much to... I don't want to go off on too much of this tangent, but I got strong opinions on it. There's just too much to remember in the field of in software engineering, computer science. There's just so much stuff, and a lot of it's syntax or how to use a library or just things that you couldn't possibly memorize it all. And when these tools exist, when we have Google and Stack Overflow, why even bother trying to memorize it all when everything's just a few keystrokes away? Don't bother memorizing things. You always use Stack Overflow throughout your whole career. I still use it. But what you really need out of college is understanding what to do with those Stack Overflow answers. That's the tricky part. Everybody can copy and paste code from Stack Overflow, but unless somebody's worked on your exact project and posted it to Stack Overflow, you're only using that for little parts of your project. And don't cut and paste from Stack Overflow in any aspect, academia or on the job. Anyway, I gotta keep moving. I can't get too sidetracked. I missed the last slides yesterday. Running out of time. So Waterfall, this is like the first real lifecycle, software lifecycle model that came out. It's very straightforward, very simplistic, and nobody likes it. I'm included in that. I don't like it. But let's talk about what it is and why. And maybe you like it. Maybe this is what you want to do. But there are a lot of attempts to improve on this, but some of them are more or less successful. I think the most successful ones are the ones that don't resemble Waterfall at all anymore. So this treats software like an assembly line. You start a project, you gather the requirements, you analyze the requirements, you design the software, you implement the software, you deliver the final product to the customer. It's very step-by-step that you complete one step before even thinking about moving on to the next step. And you can see where the name comes from. The project just flows down this chart like a waterfall. So this starts at nothing, a clean slate project, and then ends with delivering functional software, hopefully functional, to the client with documentation. And then no mention of maintenance. Some waterfall models will add the maintenance step on there to maintain the software, but no explicit mention of maintenance for waterfall as its base definition. When you realize your whole career, CS career is a joke now. Just because we use Stack Overflow doesn't mean it's a joke. Most people don't know what to do with those Stack Overflow answers if you haven't had formal CS training. Or even what to ask, what to search for to find the question that you need to ask, like to understand if you're having an issue with MongoDB not working with your Docker container, like just getting to the point where you can ask the question, why isn't MongoDB responding to my Docker container app when they're supposed to be linked? Like just figuring out what question to ask is tough. There's a lot of experience involved. I'd argue that even with Stack Overflow and Google, this is still one of the hardest careers, which is reflected in the salaries that you all get after graduation. This is still a very difficult career. It's not like Stack Overflow makes it easy. It's a necessary tool to keep our sanity and to be able to make this job feasible at all with the way the software landscape, the ecosystem has exploded over the past 20 or so years. Things used to be a lot simpler, back in the 80s or so. So I'm told anyway, but once the internet came along, holy crap, did things get complex fast. There's just so many libraries, new languages being developed all the time. It's just a lot going on really fast. So anyway, let's go through these steps. Requirements. You meet with the client. You gather requirements. You figure out what the client wants and needs. Try to focus on what they need is going to be a key part of what we do as software engineers. And this is your only chance, since this is a waterfall model, that the implication of water can't flow up the waterfall. We can't really take these steps back up. So this is your only chance to gather requirements. You talk with the client, you have a bunch of meetings, you agree on a contract, and that's the contract. That's what the project is going to be. Only if you get a job. the job market's still so good for CS graduates. You'll get a job. The only question is, will you how much you focus on your studies and not just your grades, but actually learning and applying all the content and going to hackathons and working on side projects. That's going to make the difference of if you get your dream job or not. But I don't think I've heard of a student not getting a job at all. You might get a job just designing, putting together front end web pages that doesn't really use your skills, but you'll still get a job. Where if you really pay attention, you might be designing algorithms for Google, if that's what you want to do. The internet makes it easy to realize everybody's smarter than you. That is false. That is false, my friend. The internet makes it easy for, you got billions of people on the internet. You're going to see the best of the best, and that's what you're going to be exposed to. Not everybody's smarter than you. It just means that there exists somebody who's smarter than you. It's a for each, not for all. Or there exists not a for all relationship. It's very important to know, because that can really shatter confidence. Most people are still pretty. Let me stop that sentence. So this is your only chance to get requirements. This is, in my opinion, one of the worst shortfall of Waterfall. This is your only chance to talk with the client and agree on what the software is going to be. Once you agree on the contract and it's signed by both parties, it's not changing. It's what a contract is. Then analyze that contract, come up with all the business side requirements of the contract. So the client's going to say, I need this, this, and this, and this. This is where that is boiled down into what that is actually going to mean for your business, for your software team. What are we going to need to deliver in this software? And finding anything wrong with the contract, which you can't really change, but we're trying to figure out all that stuff at this point. Figuring out from these requirements, what do we need to build? Next is the design phase. This is where you start designing what the software is going to look like. This is the first time we're ever talking about code. We made it through 2 major steps, half of this process, before even mentioning code. It's going to take all the business logic and everything that the analysis developed and turn it into an outline for the code. What classes do we need? What methods do we need? What data do we need? Do we need a database? What's that database schema going to look like, etc.? All that good stuff. At this point, after the design phase, actually, let me go to the slide first. Then we're going to finally code implementation, finally writing the code, bringing the project to reality and delivering the final software. For college classes, aside from this course, for most courses that pretty much any course that's not project based, we do requirements analysis and design for you. We deliver the design document, and then you implement it. This is the only step that you've done for most of your college career. This is the step that you focused on the most. In this class, we go from project start and go through all of this. Not with Waterfall, mind you, but you will be going through these steps yourself. Designing your own software, requirements for your software, your use cases, your user stories that we'll talk about Friday, figuring out how to actually build that, how to design the software that's going to realize that solution, and then finally, a part of this class is still actually building that, writing the code. But this should not be your primary focus in this course, or else you're gonna spend a lot more time than you would like to on your project. Why are the arrows going back? Oh, this is showing it's really tough to go back. That's why these are dotted arrows. It's very difficult to go up the waterfall. Very costly as well to go back up. Sometimes you have to, but it's very expensive in the waterfall model. All the documentation, you got through 3/4 of the process, and then you start implementing and realize there's a fundamental issue, and you got to go back up possibly all the way to requirements. All of this work that these teams have done is just done. It's just gone. The analysis are taken, so the requirements are going to be spoken in the language of the customer. The analysis has to convert that into more of a business language or a technical language to get it to a place where the designers can start designing the actual software. So what is the software going to actually do to fulfill these requirements? And then how are we going to design that software and then actually implementing that software? Business language like art, not a business coding language, but like a business language like, I mean, maybe you were joking, but I'll give you a serious answer anyway. Business language like, I'm blanking on a good example. Like this software should be able to store customers' information, would be business logic. When a customer places an order, that order needs to be tracked. Design would say that order is going to be tracked in a SQL database with these fields, is the difference between those two. Analysis is more looking at, from a human side, what do we need? And then the design is, okay, from the software side, how are we going to accomplish that? No recitations this week. I mean, technically no recitations, but you're encouraged, and strongly encouraged, to go to the Slack channel for your recitation and get to meet your classmates and form groups. You have to have form groups and have your project idea agreed upon and outlined by next Thursday. I recommend that you use those recitation times and go during the recitation time to those channels, and hopefully at least one other person does the same thing, and you can talk to each other and start forming your group, because you all have that time in your schedule. But no actual recitation. I won't have anything for you for recitation this week or next week. Week 3 is the first time you'll have an official recitation with your project managers from CSE 404. So Waterfall model, this is I would argue, the best software development model if it works. If it works, and specifically when you have all of the requirements clearly defined in this requirements phase, if those requirements are rock solid, they will never change, and the customer knows exactly what they want, this is the best way to do it. You take those requirements, you analyze them, you design some software, you implement the software, you deliver the software. The problem with this is, I was trying to set up a slide that didn't exist. It exists, it's just not the next slide. I thought it was the next slide. So when it works, this is fantastic. And as the imagery, as the name implies, as I mentioned earlier, you can't really go up the waterfall. It's meant to start here and end at the bottom without ever going up. It's very hard to go up. Yeah, it's like going down a Niagara Falls in a barrel. You can't go backwards. There's no paddling up the waterfall. So the problem with this is the clients need to know everything, all the requirements, exactly, down to every last detail, before you begin working on the project. If they don't, then Waterfall isn't really going to work. The problem is this is a very unrealistic view of software development. The client is never going to know what they want, and changes will always happen. This is the slide I was trying to set up. Changes are always going to happen during the project. The customer is going to change their mind. This is the one thing you can rely on in software development, is the client will always change their mind. They don't know what they want. They don't know how to communicate what they want. There will be changes in the requirements throughout the development of your life, throughout the life cycle of your project. The client is going to change their mind. Always. I can't stress this one enough. It's just one of those constants that you're always going to face with. Before I rag too much on Waterfall and on clients that I'm about to do, there is one case where Waterfall is good, where all these things will be met when Waterfall is pretty good. I actually I used to rag on Waterfall a lot because it's just so silly it's so naive to think that Waterfall would be a good model. It is very good in certain situations. One, in a lot of engineering applications outside of software engineering. If you're building a bridge, for example, your requirements are well defined, well in advance. and you can use a waterfall method. In fact, you shouldn't start building the bridge before you have everything designed, and that's just a perfect place for waterfall. Within software engineering or building a building, same thing. With inside software engineering, actually, because I would rag on waterfall a lot, I actually got some kickback from people from industry, like, hey, we use waterfall and we use it effectively. And building a bridge over a waterfall. Oh, we're getting meta. And where they worked were in two specific industries, healthcare and finance. These two industries are heavily regulated. There are lots of government regulations as well as just moral regulations. If you mess up a piece of healthcare software, like inside a machine in a defibrillator, for example, people can die. So you need software that works and is fully tested, fully documented, and you can't just dive in and deliver a prototype like we're going to talk about in a few slides. You just can't do that. And in addition, the requirements are actually specified through the regulations, and through, like, a defibrillator has to do this very, very, very specific thing. It has to deliver this I'm thinking of the right thing, right? This voltage through these contacts using this hardware. Like, it's very specific what it needs to do. So you actually do know the requirements ahead of time, and you know what you have to build. That's when waterfall can work really well and can really shine in those two industries, finance and healthcare. Healthcare, people could die. Finance, people don't like losing money. If you say you're writing an auto trader for an investment company and you've got a bug in that, the company can go bankrupt in a matter of seconds if it makes the wrong trades. So those are two, plus the government regulation on top of that. There's a lot of things that are defined for you. And the 747, was it 747? Yeah, the Boeing planes that had that software malfunction. I mean, people die. That's serious stuff. That's where waterfall. So waterfall has that advantage: is you're delivering to the customer once, and it's fully tested, and you're guaranteed that it works. But let's just get to the other ones. Is most of the other development life cycles will talk about deliver incomplete software multiple times. You can't do that in a 747 or a defibrillator or an automatic trader that trades on the markets. You can't do that. So anyway, that's one defense of waterfall in those industries. But realistically, when the client isn't ordering a defibrillator or a heart monitor system or something, they don't know what they want. Waterfall assumes they do. This isn't realistic for most clients. If you're building a website for a client, they have no friggin' idea what they want. They probably don't even know what you're capable of or what their options are. It's going to take a long time to figure out what they actually want. Got to get a waterfall. There might be a lot more hydration than you want. So which brings us to our next one. So let's rip through a couple more of these before we get to the one that we'll use this semester. So rapid prototyping, it's going to take the same steps as waterfall, but with the idea of running through the waterfall much more quickly, getting to delivering software faster, delivering that software to the user, getting feedback from the user, and then going back up to the top. And I'd argue that this should go right to the requirement stage. You're getting new requirements from... Oh, actually, it does say requirement changes from the feedback. So this is kind of replacing this. I see how the chart's talking to me. But you're getting new requirements, then going back with those new requirements, go through the whole process again, deliver again, talk to the client, go through the process until you have some functioning software. This means going through these stages faster. We're not worrying about getting the perfect software design, implementing everything perfectly, analyzing everything perfectly. We're just ripping through these to get something released to the client. Charts can talk to you too. This chart's not talking to you. You may have to... I don't have an appropriate joke to follow that up with. I'll pass. So this can be nice. It helps you talk to the client. Turn on text to speech. It helps you talk to the client more. You want more of a dialogue with the client, because when they don't know what they want and they're changing their mind all the time, if you're having more of that dialogue and that back and forth, especially when you're showing them functioning software, it can really guide that development. It's very often you'll have that first delivery to the client, and what we'll call them sprints with Scrum. But you go to the end of that first sprint, you deliver that client software to the client, you demo it to them, they look at it and they say, oh, wait, this is kind of what I didn't think this is what we were talking about. Can we change this, and that, and then add these features and this? You're going to get a lot more feedback, at least in my experience. You get a lot more feedback from the client when you have working software, maybe not with all the features, usually not with every feature, but something running in front of their face. You're going to get a lot better feedback than when you're just talking, and sketching things out on a whiteboard or whatever. You're going to get a lot more feedback and useful feedback and clarification from the client on that first delivery of the first prototype. This can cause confusion too, because a lot of your features won't be done. You'll have a button that says, click me and I'll do this thing. But you click it, it won't actually do the thing. So the client can get confused. This is one of the cautions you have to use with this. When they think it's done and they think everything's functional, when it's not, when you have tons of work still to do, they might wonder why it's still going to take you another 6 months to finish this software, when very early on you're showing them the first prototype and they think it's finished. Blackboard wasn't made by UB. Don't get me ranting on Blackboard. Maybe after a lecture I can, but so rapid prototyping kind of slows down the waterfall a bit. Has these extra landings in there. Change is the one constant. Spiral, I won't talk about this too much because I'm again not spending too much time talking on each slide. But a spiral life cycle was kind of born out of that idea of rapid prototyping, is that we're going to constantly go through the whole life cycle and deliver lots of prototypes. And the key part of the spiral life cycle is that you're going to analyze the risks before each prototype, deliver that prototype to the client with the risk analysis, and decide whether to even go on with the project or not. To go on with the project or just kill the project right there. So this is great for very risky projects. If you have some very experimental idea that you might want to work on with a client, then you can keep going back to the client and saying, hey, it was experimental. We did some analysis, and we found out that you're going to have all of these costs also that we didn't foresee in the first meeting. And then they might say, oh, those costs are unacceptable. Let's kill this project. Or, no, these costs are fine. Let's go one more step of the spiral. Talk to me on the next step, and then with a new estimate, new revised estimate, and so on. So this is great when you're going into unexplored territory. You have no idea what the project is going to entail. Then the business people can make those decisions at each step of the spiral and just kill the project if they don't like how it's going. And the development team has that understanding that the project can be killed at any time. So you kind of manage the risks, manage the emotions, I guess, and manage like doing extra work. Maybe somebody wants to write a bunch of documentation for a module they wrote. When you're in the spiral life cycle, you say, well, maybe let's not waste our time on that because this project might die tomorrow. So that's where spiral really shines. Iterative development, one other development life cycle that we'll talk about. It's like Waterfall, but works incrementally, similarly to the spiral, similarly to rapid prototyping, but with some key differences. Here we're going through the entire waterfall, each step of the development process, but we're usually only developing one piece of the software instead of a full prototype that's supposed to be fully functioning software. Oh, that's one of the downsides of rapid prototyping. Usually a lot of features are broken. I kind of mentioned that, but I want to make that explicit. Here the features aren't broken, but you're developing one piece at a time and just slowly developing the whole project. So that one piece that you deliver after each iteration is a fully functional, documented piece of working software, and then you will build another piece on top of that instead of trying to build the whole project kind of crappy and then improving each iteration. Here we're building each piece of the project one at a time and then getting feedback after each step is done. So this is more like I don't know what this is called. It's a dam clearly, but you're really controlling the flow of the water as it's going down. I don't know what that's called, but visually that's the idea. Which finally brings us to, oh man, I deleted a bunch of slides to get to this sooner. I still only have 7 minutes. Finally gets us to what we're going to use in this class. We're going to use a form of agile development called Scrum. Or Scrum, we don't call it by name in this slide deck, but we're going to use some of the terminology of Scrum and mix it in with the introduction to Agile. For example, sprints are not defined by Agile development at all. Agile is a verb. It's a way of developing software. You develop software with agility, but it isn't a clearly defined software development lifecycle, where Scrum is. It takes the ideas of Agile and adds some structure to it. So just so you know, Agile and Scrum are going to be mixed together in these slides. So Agile says, or Scrum rather, after I just said all that, is born out of this iterative development process where we're going to develop pieces at a time, and also the rapid prototyping. It's kind of a mix between the two with some extra stuff. And the big part here is that the clients don't know what they want. Changes are going to happen. Let's embrace that. Let's embrace that and just plan around that and design our software lifecycle to expect changes. So similar to the rapid prototyping. And this works through a series of sprints. Obviously, this semester, as we talk about Agile and Scrum in these slides, you'll see that the course was designed with this in mind. We have a series of short sprints where you deliver software at the end of each sprint. At the end of each of your 4 sprints, you're developing working software, and you're going to demo that software to your project manager. And then you can reassess your requirements, reassess the project itself. Your team can decide to go in a different direction, change some features, whatever. But you're going to deliver software at the end of each sprint. So at the end of September, you're delivering your first piece of functioning software of your project. And testing it. Testing is important. We have some lectures on that next week. So coders usually just do what comes naturally, which isn't always the best idea, where like Waterfall was trying to fight against what we naturally do, which is, Bob from the beginning of these slides, we like to just jump into the keyboard and start typing code. Not always the best idea, but Agile kind of embraces this and says, you know what, developers like to just develop. Let's embrace that a little, which is kind of like accepting failure and just wiping out all of the software development lifecycle ideas, all the things we just talked about. But it adds enough structure that seems to work well. It's being used in industry quite a lot. It's withstanding the test of time. And I personally like it. I like this one. Coding with agility. So it's kind of like saying, wait, we already said that was bad. That's why we started Waterfall and went down that path. But look, a lot of projects fail anyway. Like, nobody has an answer here to developing software. This is still a really young field. It's a young industry, which it's only been around for like 50 years or so, to any large-ish degree, and only really 20 years since the dot-com boom and everybody started having computers in their homes. That only happened in like the 90s when everybody started having a PC in their home. Very recent stuff. So this industry hasn't even been around for very long. So we're still all figuring this out. Agile and Scrum right now, Kanban and Extreme Programming and a few others seem to be the ones that industry likes right now. They probably won't be for very long. There will be something new that comes out. But we're all figuring out how to write software. Nobody really has the answers, which is why so many projects fail. So the Agile Manifesto, I saw this in chat. We will talk about it, and this is the only time I will read a slide verbatim. I shouldn't say only, there will probably be some other case. But we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. Whenever somebody talks about Agile or Agile development, or they're trying to sell you an Agile course or a boot camp or whatever, this is what they're talking about. This is Agile. This is the Agile Manifesto in its entirety. This is the entire thing. So this is where everything comes from with Agile. I shouldn't say everything, because the next few slides we're going to talk about a little more. This was written in also 12 principles. I forgot what they were called. Also 12 principles, which were quick one-liners that the authors wrote, just to kind of expand on what they mean by that manifesto. So the 12 principles: deliver valuable software early and often. For Scrum, we call these sprints. Sprints are usually 2 to 6 weeks in practice. They're almost said the wrong one. 3 weeks, 4 3-week sprints this semester. So we have 3 weeks. We're a little on the low end of this. I've heard of 1 week sprints before as well. They exist. Welcome changing requirements. This is really the cornerstone of Agile development. You expect things to change and you react to those changes with agility, hence the name. Business people and developers should work together daily, not like Waterfall. You have that one meeting with the business people, hash out the requirements in the contract, and then you don't see the business people again. Business people and developers should work together daily. They should always be communicating and making sure the project is what it's supposed to be. Build projects around motivated individuals and get out of their way. Give them what they need and get out of their way is a big thing. Communicate face-to-face is a lot tougher with the pandemic, but I'd say at least over Zoom with webcams on. I don't know if they still do this with the pandemic, but Google wouldn't hire anyone if they couldn't be on location. They wouldn't hire remote employees because they need face-to-face, because that's how better software is written. Remote employees, you just don't have that communication. I've worked with remote employees before. They're just naturally out of the loop. You don't have those little, water cooler conversations. They don't have that communication that they have. The manifesto and the principles were actually written over a long weekend. A bunch of people got together and they wrote this, sat down face to face. They weren't communicating over email or anything, face to face, and came up with this Agile, which kind of rocked the whole software engineering world. Working software is the primary measure of progress. That should be self-explanatory, but Waterfall focuses a lot on documentation and contracts and things like that. Things that don't have anything to do with working software can be related to, but not that there's not value in documentation, but working software is the primary measure of success. Not to say it's the only, but primary. Agile processes promote sustainable development. If you have agility, you're not gonna, I think that when if you're developing with agility, you can develop forever. You're not gonna get burnt out because you should be working at a constant pace. Oh, it's right there, consistent pace. Hence the sprints. You deliver software often. You're working in sprints. You're not working on projects where there's one big project deadline. You're just used to all these little deadlines. It gets a lot, you get a better rhythm that way. Continuous attention to technical excellence and good design enhances agility. This should go without saying as well, but it's nice to have it recorded, is one of the Agile principles. Good encapsulation, things like that. Are always a good idea, of course. Simplicity, maximizing the amount of work that you don't do. You ain't going to need it. Yagni. It's always tempting to build a feature like, we're going to need this someday. Just don't. Wait until you need it, and then build it. And the best architectures, requirements, and designs emerge from self-organizing teams. That's why I don't create the teams or make random teams in this class. I let you organize yourself, and ideally organize around an idea instead of just getting together with your friends or whatever. But if you just want random teams, that's fine too. But I will give you that option to self-organize. At regular intervals, the team reflects on how to become more effective. This is usually at the end of each sprint. You reflect on the project, decide what features you want to move forward with on the next sprint, which features can sit on the back burner, what's working, what's not. You adjust everything after each sprint. Some teams even do this every day. They have daily stand-up meetings. If you're on a true Scrum team, every single morning, you get together with the whole team, face-to-face usually, except probably not now during a pandemic, and talk about the direction of the project and reflect on that a little bit, as well as keep everybody up to date on the progress of the project. So that's Agile. If you hear anything else being called Agile, they're wrong. That is Agile. And some of that was actually Scrum. That was more than just Agile, by the way, as I mentioned earlier. So just a reminder, make sure you're in a team of 5 with your project idea fleshed out and your GitHub repo and your ZenHub account all created by Thursday, September 10th, 11:59 on that day. Make sure you're doing that. If you don't have a team by now, get on that. Start doing that. If you're absolutely having trouble finding a team, message me on Slack by the end of the week, and I'll do what I can to figure something out. I'll probably just go in your channel and say who's not on a team yet, and anybody who says yes is going to be your team. So I'd recommend you just do that. You would save me some time, honestly.